116, talking about mechanical energy and work. An object with mechanical energy can do work on another object. In fact, you can think of mechanical energy, like all forms of energy, as the ability to do work. So, for example, a basketball does work on the net as it falls through the hoop. The net moves as a result. The more the mechanical energy an object has, the more work it can do. So let's calculate out. The bowling ball does work on the pins when it hits them. Why is the bowling ball able to do work? Next question. How should you throw the ball to maximize the amount of work it does on the pins? Go ahead and stop the tape and answer that question. And number 3, in the type of bowling shown in the photo, the ball has a mass of 7 kilograms. In candlepin bowling, the ball has a mass of only 1 kilogram. Does the ball with a greater mass always have the greater mechanical energy? Yes or no, and explain. Let's go on. Define. Mechanical energy is the form of energy associated with what? With the blank, or blank of an object. B, calculate. At a certain point, the kinetic energy of a falling apple is 5.2 joules. Its potential energy is 3.5 joules. What is its mechanical energy? Remember, we went over mechanical energy. What was the equation? So look that up. If an object's mechanical energy is equal to its potential energy, how much kinetic energy does the object have? So think about and infer what you know about those 3 terms. Now I know you can find an object's mechanical energy by doing what? Then let's go up here to what are other forms of energy? So far you have read about energy that involves the motion, position, the shape of an object. But an object can have other forms of kinetic and potential energy. These other forms are associated with particles that make up the object. These particles are far too small to see with the naked eye. So forms of energy associated with the particles of objects include nuclear energy, thermal energy, electrical energy, electromagnetic energy, and chemical energy. So let's go over some of those terms. Nuclear energy. All objects are made up of particles called atoms. The regions in the center of an atom is called a nucleus. A type of potential energy is called nuclear energy. It is stored in the nucleus of the atom. Nuclear energy is released during a nuclear reaction. So one kind of nuclear reaction, known as nuclear fission, occurs when a nucleus splits. A nuclear power plant, like the one shown in Figure 2, uses fission reactions to produce electricity. Another kind of reaction known as nuclear fusion, so see the spelling difference? F-I-S-S-I-O-N and F-U-S-I-O-N. Nuclear fusion occurs when the nucleus of an atoms fuse or join together. Nuclear fusion reactions occur constantly in the sun, releasing a huge amount of energy. Only a tiny portion of that energy reaches Earth as heat and light. Controlled nuclear fission reactions occur at some power plants. Nuclear fusion reactions usually occur in the sun. Use the Venn diagram to compare and contrast nuclear fission and nuclear fusion. Go ahead and shut the tape off and try the Venn diagram.